This is problem 4 in review for confidence intervals. The following data show the number of hours per day 12 adults spent in front of screens watching television-related content. So we're going to take the data and we're going to pull it up in StatCrunch. I'll slide this over here so we can use it here. The first thing we want to do is construct a 90% confidence interval to estimate the average number of hours per day adults spend in front of screens watching television-related content. So what we'll do here in StatCrunch, press Stat. We're not given the population standard deviation, so we can't use Z-stats. We're going to be using T-stats in this case to estimate the mean. So we've got one sample, and we actually have the data. We don't have the sample mean and the sample standard deviation. So in this case, click the variable for the column. We're constructing a confidence interval, and that confidence interval has a confidence level of 90%. So I will do that, compute. And so here we have our lower limit and upper limit for our confidence interval. So over here, rounded to 2 decimal places, we'll put in 3.36 as the lower limit, up to 5.77 for the upper limit. So we've constructed a confidence interval from data to estimate the population mean. And here it says what assumptions need to be made about this population. Well, when we're conducting such a test, we need a simple random sample, and we need X bar, the sample mean, to be normally distributed. And there's two ways that we can get that normality. One, the population that we're sampling from is normal. And the second is we have a large enough sample, n greater than 30, that we can use the central limit theorem to assure us that X bar would be approximately normal. In this case, our sample size is 12. So the central limit theorem is not going to save us. What we need to assume is the population follows a normal distribution. And so here, the only assumption that we need to assume is stated in part B, that the population distribution is normal or approximately normal. So B is our best option. I hope this helps.